Hiya there! I am Esmerelda, and you're here to know some science stuff, am I right? Well, first, I am a good witch, a smart science nerd perhaps, and I am here not to curse, but to give enlightenment. Okay, too much talky-talky. Let's get on to my world. Come on, and let's venture into the world of, guess it, chemistry. Specifically, the Avogadro's law.
Esmeralda in her science world.
By the end of the video, we'll be able to explain the interrelationships of volume and amount, or mole, of gas under constant temperature and pressure, and be able to use the equation for Avogadro's law to determine the changes in volume and amount of gas. Once upon a time, in a far-away period of time, there was a man named Amedeo Avogadro, who was an Italian physicist, born on the 9th of August, 1776, in the Kingdom of Sardinia and Piedmont, Italy, and later died on the 9th of July, 1856. He is known for his contribution and developed what became known as Avogadro's law. Avogadro's law, developed in late 1812, is a law that states under controlled conditions of temperature and pressure, the volume of a gas is directly proportional to the amount. Equal volumes of gases contain an equal number of molecules.
To prove this statement, he conducted an experiment.
He prepared 2 identical test tubes for this experiment and fitted both with a piston cylinder assembly. In the first test tube, he added about 0.10 moles of dry ice and 0.20 moles of dry ice in the second test tube. When the dry ice became gas, in room temperature, and the pressure of the dry ice became equal to the atmospheric pressure, he noticed that the volume of the second test tube is equal to that of double the first test tubes.
When this relationship is represented in a graph, we'll have something like what is being shown.
When written in mathematical terms, we have volume is directly proportional to the amount. Therefore, if we have gas in 2 different conditions, this can be written as volume sub 1 over amount sub 1 is equal to volume sub 2 over amount sub 2. Based on the formula, we can conclude that under certain gas conditions, increasing the volume results in an increase in the amount of gas, or decreasing the volume would also reduce the amount of gas.
Hard to fathom? Let me give you an example.
A 6-liter sample contains 0.5 moles of gas. Under the same pressure and temperature, another 0.25 moles of gas was added. What is the final total volume of the gas? For this example, our initial volume is 6 liters, and the initial amount is 0.5 moles. So here is how to solve. To get the final amount, we simply add the initial amount to 0.25 mole. And as you can see, the only variable remaining is the final volume. To get the final volume, we simply divide the product to initial volume and final amount by initial amount. Thus, we get the answer, which is 9 liters. Here's another example. Initial volume is 1 liter, initial amount is 1 mole, final amount is 2 moles. Since we don't have the final volume in the given problem, we will just substitute our given values into the formula of Avogadro's law, giving us our final volume to 4 liters.
Avogadro's law has applications in our daily lives too. A great example would be our breathing. When we inhale, our lungs expand, getting filled with air. Similarly, when we exhale, the lungs let the air out and shrink. I hope you all learned today from your friendly witch. See you in the next video, curious kids. Baboosh!